without further ado, I'd like to introduce our first speaker in the next panel. She is one of Ford's top specialists in manufacturing technologies, based at the Advanced Research and Development Center in Aachen for manufacturing. Has had 20 years experience across many manufacturing and analytics roles, and we're really pleased that she's here to present to us today, Dr. Seonhi Ro from Ford Europe. Thanks very much, Seonhi. So the stage is yours. We'll hear from Seonhi, and then we'll be joined in a panel discussion.
So, good afternoon, everybody. Thank you very much for having me here. Today, I will give you just some overview how the factory of the future looks like. So first, I will start with the definition of Industry 4 and Industry 5, and then go to our automotive industry transformation process, and then give you some ideas how the technology hype curve is working. And the main part of my presentation is product lifecycle management. There I will give each product lifecycle phases which technology we are using, and there's some practical examples. And then finally, I will give you some idea how if we apply all those technology, how the factory of the future looks like, and then Q&A session. So I think you know already all what is Industry 4.0, but in order to get the same basis, I will start with the first industrial revolution, which is production infrastructure revolution using the steam power. Second is mass production with conveyor using the electricity. Here, Henry Ford was the main contributor for second industrial revolution. And the third industrial revolution is automatization using electronic and IT system. Industry 4.0 is cyber physical system using completion of digitalization and the internet connection. Here, cyber means internet, and the physical system means things. So a lot of people speaking about Internet of Things. Now, the European Union is speaking about Industry 5.0. Until now, the industries focus on only shareholder values and the productivity efficiency. But with the time, we are recognizing there is something missing. Where is humans in there? And we recognizing also our planetary resources are limited, and also climate change is coming. So what we can do? So Industry 5.0 is not actually the real industry revolution, but it is complementary to Industry 4.0, but we have three different area focus. The first area is sustainable. The sustainable lead actions on sustainability and respect the planetary boundaries. And second element is human-centric. That promotes talents and the diversity and the empowerment. And third element is resilient, is agile and resilient with flexible and adaptable technology. So now our automotive industry is transformation phases to Ks. So here C stands for connected, A stands for autonomous, and the S stands for shared, and the E stands for electric. And in order to get the sustainable business, we need to have a robust product lifecycle management using this all Industry 4.0 technology. And let's see through quickly how the technology hype curves is working. And we have an example here. Technique is, innovation is triggered. And first, the expectation is increasing rapidly. And then some point of the time, the people recognize there is still a lot of roadblocks as it takes more time to really implement. And then getting the disillusion phases. So a lot of technologies or some of technology disappeared in these phases, but the technology survived this deep point. It is getting robust development and get the productivity. But this time, this robust development is taking much more time, like this hype. So we need to consider all new technologies that takes time, more time than we expecting. So the product lifecycle management, if we talk about product lifecycle management, we are starting in the design phases. If we design and then come to procurement the materials, and we have produced our cars, and that is transported to the user, and we have also using the customer is using the vehicle. Here we have a lot of mobility data. And then after customer use the vehicle, it is going to the remanufacturing or recycling. During this all phases, we have a lot of data. And if we can analyze this data, then we can have very robust product life cycle. So that is a long time goal to get all this data, but you cannot get all the data in one. So you are picking where is possible the data and collecting all the completeness. And there we have different technologies in the development phases and production phases. And if we see the blockchain or AI or wireless communication, those things are whole the life cycle, we can use it. So let's go quickly technology by technology. So first technology we using, that's just example, is the new vehicle 360-degree sketches. In the former times, if you have the drawings, it takes a lot of time to get 3D model. Now, with this tool, directly you can sketch it and you can get this 3D model. So you can get from your customer direct feedback, how it looks like, he likes it or not like it, or feedback. So we can have very early phases our development, already feedback from the customer. So this inspiration is coming from the game industry. So it is, at the moment, we have a lot of investigations what we can use from the game industry, because in game industry, all visualization is really important. They have a big technology jump, so we need to look through it. And then second method is generative design. Generative design is autonomous geometric design after specification and constraints. So there is three categories. The first category is topology optimization, and second is biomimicry, third is morphogenesis. In the first topology optimization, we are using the technology, subtractive technology. An example, if you have designed this right-hand corner, this part conventionally, we see through it, and this between the holes, this part are not loaded. So we can take out those parts and go iteration, then you can get the final parts here, which has much less material and the weight is lower. And the biomimicry is algorithms considering the nature behaviors like trees or the bone structure, leaf structure, and something like that. And morphogenesis is opposite of the topology optimization. It is not subtractive, but from the beginning, where the material is loaded, is growing faster. So that design is doing that automatically. If you are using this, there are several softwares you can use it. But when you use this design, then some of cases, it is very difficult to produce with a conventional production method. So that's why the additive manufacturing is coming. Probably quickly, the right-hand side is an example. That's a factory tool. The upper side is, here is the our conventional design with the metal. That's polymer material. We optimize the topology optimization. So we can have, tool itself is much lighter, and then we can get or much faster produce. The polymer additive manufacturing is at the moment standard. We are using a lot of cases. And the metal additive manufacturing is still progress. And also we are discussing 4D printing. And at the moment, many prototypes or tools and low volume parts, we are using this additive manufacturing. But we are also investigating the high volume, how we can make this additive manufacturing in the high volume. The problem at the moment is additive manufacturing has a lot of manual pre-processing and post-processing. So that needs to be optimized. And if we can get that achieved, the cycle time is acceptable enough, then we can put in the everywhere. If it is successful, you can have also as a service some 3D printings. If we have no capacity, we can, anyone ask with our digital models and they can deliver us. So that is also one of the thing which we also investigating. And I think I don't need to go through all definition of VR, AR, and mixed reality. What we are using for virtual reality, augmented reality is first, I showed in the product design we use it, but we are using also in the manufacturing process. So in US or in Asian or in Europe, manufacturing guys going through together, and you can put the comments, and so it's a very useful tool. And also we are using virtual training and the ergonomic assessment. That's done all digitally, so you can train your operator much easier, and then you can get already feedback. Then you can already correct the material before you produced it digitally. So it does not cost a lot of time and money in this, if we can do already in these phases. And then for the vendors, I think it's important that we go into direction virtual commissioning. It is not replacing physical commissioning, but we do first virtual commissioning in order to get physical commissioning more effective. And what we are doing is we have 3D layouts, and then vendors deliver dynamic models. We can already put in the 3D model, and then we can go through any issues and modifying the design. So it is, I think at the moment we have, some of vendors are capable to deliver those models, but some of vendors are not capable. So that's probably you need to consider. And then also workstation readiness and the dynamic plant simulation, where is too much loaded, there's not bottleneck analysis. That's all the part of the digital twin. Okay, then we have cobots. It's also very standardized process. We have overall a lot of cobot applications. Here is the video for Cologne plant, but due to time constraints, I will not play, but you will get the link, then you can see through it. And it's like colleagues from him, and even some people give the names and talking to. It's better other human colleagues sometimes. Okay, then we have AGVs. You have seen a lot of examples already, some other discussions. And then we have drones, an example in the Dagenham engine plant. We are going through, with the drones, we are going through all inspections, especially in the highway. Normally you need to have a scaffold, the operator needs to go up and then see through all the things. But with the drones, you can see already, and then you can prepare all the maintenance work and plan it. And then we have in the robotics, we gave the name Fluffy, and Spot. Spot is given from Boston Dynamics, and the fourth name is Fluffy. Fluffy is, he has the cameras in his bag, and 5 cameras, and he's scanning all the plants, and you can get the 3D models already. And in the former times, the people are doing it to take weeks and weeks, but now some hours they can do that. And then we spoke about a lot about supplier chain management. It is one of the things probably is promising. Blockchain is used at the beginning in the Bitcoin. Therefore, there is a lot of mixed image in the blockchain. But it is technology itself is a very interesting technology. All participants in the value chain, they approve their ledgers. So in the raw material and going through all the chains, we can have the all data that's like a digital fingerprint, and we can have the clear and safe documents. But the problem at the moment is it costs a lot of computer capacity. So we are investigating combining with the AI blockchain. Probably we can reduce the computer capacity and so on. And then wireless factory. So do I have the time to play the video? So can you play the video? It is some pilot project we have done with Vodafone.
We've got a long history of manufacturing vehicles with internal combustion engine technology, but we're in a process of total transformation. For us in Ford Motor Company in Europe, we're ready to deliver that significant pace of change in terms of the adoption of plug-in and fully electric vehicles.
We have to very rapidly redeploy all of the assets that we've got into factories that can meet low carbon vehicles by 2030. The factory of the future is all about moving data, and 5G is an enabler for that. Ford has a long-standing partnership with Vodafone. Building a pilot line with 5G was a great opportunity for us to then look at the technology, understand the technology, and without this learning, we wouldn't be able to consider doing this in one of our plants.
One of the use cases here in Dunton, using the Vodafone mobile private network, is on our welding machines. So we're capturing images before we're welding and then after we're welding, and then we can use AI and feed back to the machine if the weld isn't particularly good, and then change and re-weld whilst the part is still in the machine. You could be welding and creating terabytes of data very, very quickly. So it's important that we have the connectivity that can keep up with that and that could send that data and store it as quick as we're producing it.
We've been able to see data back from the laser process that tells us that we're getting a buildup of heat in our lenses, which means that we need to replace them. We could then contact an expert to discuss it, but we can also use the 5G network in conjunction with a HoloLens system to guide an operator through the process of changing that lens. We're keen to make sure that we can connect securely, and of course with 5G you have the ability to use SIMs on every single device and make sure that you're aware of every device that's communicating on your private network.
We've got plans to totally transform our vehicle lineup over the next 10 to 15 years. The manufacturing engineering team are at the centre of the change of EV powertrain in Europe, and this team needs to work with people like Vodafone so we can do that as efficiently as possible.
Okay, thank you. And someone recognized which vehicle was in the picture. That's the Mustang electric vehicles, Mach-E vehicle, which you can get probably now already purchased. So there are a lot of benchmarking for Tesla and Mach-E, and that's getting much more interesting. Okay, good. Finalized how the factory of the future, or summarized. So we will have integrated planning and execution. If the customer can order the vehicles is already available. You can order Mach-E already electrically, and that order is translated in the planning phases. So we can plan our vehicle build, and in the future, it is still not the case. You can see that as a customer, where is your vehicle at the moment in the press shop or body shop, whatever, and then we can predict it when you will get your vehicle. And then also it will be self-monitoring and self-adaptive logistics, and the trucks, we get all GPS data, so we know exactly where our materials are. And also intra-logistics is doing something. We will have smart shelves, so it is reducing the number of parts that they order automatically and then can be delivered. And also autonomous driving within the factory. If the vehicle is completed and the vehicle, normally the driver get into and then drive, but now we are investigating the car can drive alone, go to the end of lines, quicken rattle test or whatever. And to the release, actually, you can extend it in the logistics, but that need to be all tested. And then we have wireless communication. In the production, we have AI optimized, built, flexible, and integrated production plan, and predictive maintenance and the predictive quality. Actually, it's near to zero failure. That will be implemented. The digital twin will be part of them with IoT and cloud connection and edge computing. And interaction between AI and the human will be also a key element. And the robust product lifecycle management with blockchain and AI, that will give us sustainable business. So human-centered, resilient, and sustainable factory. Thank you very much.
Thank you, Seonhi. Please have a seat and join us. Thank you so much for sharing all that information on the factory of tomorrow. And I think the positive thing is that quite a bit of it is actually increasingly part of the factory of today as well. So not all those technologies are anything like far away, and there's real applications for them. And great to see some of the stuff from Dagenham there. You would have seen the news, I think, this week. Ford, with some help from the government, is investing indeed in Dagenham and in Halewood to convert some of those factories. So there was some worry earlier in the conference that public money isn't going to convert the right places, but sometimes it is at least too. But let's talk a little bit more with our other expert as well, in how we can achieve some of these technologies and some of these visions that Seonhi lined up. So I'd also like to invite to the stage one of the leading architects for Azure at Microsoft. He's had considerable experience as well in automotive manufacturing, with a focus on data standards and open source. Erich Barnstedt from Microsoft. Thanks so much for joining us, Erich. I will hop over this way. Okay, great. So Erich, now that you're here, why don't you, I want to turn to you first, and sort of having seen the presentation and obviously this view towards more integration on product lifecycle management, on connected factory, what's your kind of rating of where we kind of are right now on this journey? If we talked about Industry 5.0, maybe we back up to Industry 4.0 for a second. What's the progress on having achieved that from your point of view as one of the leading technology providers in the sector?
So yeah, thank you for inviting me, first of all. I think lots of companies are actually very far in trying out these technologies and actually bringing some of it into production, but overall there's still a lot of runway to go. I think overall the transition to electric vehicles is a great opportunity to accelerate some of those efforts. And again, the technology is readily available. So now is the time to invest, and now is the time to leapfrog some of these old proprietary systems that have been running for 30 years and replace them with something more modern and, actually put these things into production. So we've been doing POCs and trying out all of the technologies that were just presented for many years, but only now through these, transitional phases of bringing, the electric vehicle to life, do we see some of these actually being rolled out.
And you answered but whether my next question about whether this transition to electrification and sustainability is and should be an accelerating factor for this. And Seonhi, in your role and in the research that you do, also from the center, is that the case increasingly for Ford? Are you seeing an acceleration to these technologies to respond to these changes?
Yeah. It is not only Ford, but also for all automotive industry is the opportunity, and actually it is not surviving without having those technologies. First, in the green field, we can build already before we are producing already those technologies in, so we do not need to install the sensors later and the data in the PLC reprogramming to get all the data out. So in the green field, you have a much more possibility to do that. And second is you have listened today about all this documentation, 100% documentation, and all these quality checks. It is not possible now anymore to do each documenting manually. It is done everything automatically and saved or stored in the cloud. Probably you will not have any more storage to save anywhere in the on-site, or will cost much more. So you're using cloud, and that will be everything, the support to go to the digitalization, especially if you go to the quality check. That's it is need to be done inline, because if you have done some steps already and you have already battery pack welded, and afterwards to opening all the things, it will cost a lot of money. So you need to scrap it everything otherwise. So it needs to be each steps. So you do your operation need to make sure there is no failure. So it's going to PPB.
Parts per billion.
Yeah. But it need to be zero failure. Otherwise, in the vehicle, we will have the battery failure. Then we have no possibility, like engines, to tear down it and everything. So it is necessary to go there to do digitalization. And the digitalization is not ending. So a lot of people thinking, I have now the data, it is already done, but it is not the case. You develop something and with AI, but AI is never 100%. So you need to develop further with your experience to put into the input data, again, your new knowledge, then it is developing further. And that is a lot of pain for the operator if they repaired or something wrong thing is done, and to put also documentation what they have done it. That's actually also important point. That's also doctors are complaining, the medical phases. They saying, oh, I have so many documentation, but it will help next operation, not happening those failures or whatever.
In important details, and I think the point is especially on the battery, that it needs to be in line, because if you have a failure somewhere else, you lose everything else. So that's a really important driver, it sounds like. Erich, one thing I wanted to hear more from you about, I mean, you work quite a lot on sort of open standards and establishing this. Can you talk a little bit more about how the role that is or should play in unlocking the potential of these technologies?
Oh, I'd be more than happy to. So I think two of the main standards that will be important in this transformation is one is OPC-UA as the kind of shop floor interoperability standard. I think I have a slide on that. So, we have a lot of experience with this, and we can really recommend it. Most large manufacturers already make it part of their RFQ processes for new machines, so you can't basically get a new machine installed in those automotive manufacturing plants without an OPC-UA interface. So I think OPC-UA is really important and will play a dominant role, especially for our automotive manufacturing. The other standard, which I think is just emerging, but it's already playing an increased role, is the asset administration shell. It's mainly used for the life cycle of parts and potentially also automobiles. So this is something that we've been involved in also from the start as Microsoft, and we're rolling it out into our Azure portfolio. So the asset admin shell, again, will also solve things like the digital product passport, which will be legislation in Europe in the next few years. It'll be built into the battery passport, which is the first part of this legislation. So really, I mean, if you need a standardized approach to report on data from your supply chain, the asset admin shell is made for it. We've been using both OPC-UA and the asset admin shell in a collaboration actually with the German and US governments for reporting carbon from the supply chain. As you know, in manufacturing, reporting your own carbon emissions is actually quite simple, but trying to report all the carbon from your supply chain is very hard. So the asset admin shell can give you a huge help there to actually standardize the reporting of carbon. And so I think those two standards will for sure play an important role, and you should definitely check them out.
Well, thank you for sharing more on those. I'm sure they're familiar to some of our audience, but obviously if there's more information that you need or require, I'm sure Erich can help further with that.
You can email me, yes.
Seonhi, one of the key trends you pointed to and enablers, let's say the goals of some of the technologies is really to integrate that PLM, that product lifecycle management. And right from the beginning of the conference, we've been talking about speeding up development times and faster to market. I mean, this seems like a real way to do it. And obviously, link your customer order to your engineer to the factory, all kind of at once. It sounds great. But again, what are examples for you where that can go further where it is now to get to really realize this vision?
Probably I can give in the customer side. We have the dealers normally between that before the bakery is ordered by dealers, but now the customer is able to order directly. So dealers are very worried about that, and we have a lot of cooperation with the dealers. They need to define their roles differently than we have at the moment. At the moment, it's just ordering and some service actions, but they will have much more consulting the customer, because they have already very good relationship to the customer. We don't want to lose it, so we need to define it. There is a lot of work. Actually, whole market needs to work together. That is one thing. The other thing in the product development and manufacturing and this logistics, there is we are trying to use in the team center as a centric and go to all data connected with the team center, with the test simulation, all specification is connected, and also it is compatible to the manufacturing process. So manufacturing can also already see design phases. They need to run parallel. Here is again the agile process is required to back and forward to get the optimal solution from the beginning, not to thrown away to the manufacturing and go there and then a lot of problem again back and forth. That is a problem. And also here need to be very close communication in the logistics. What is also the all logistic cost and also CO2 if you transport it, and to get those data. And there is connecting to, again, to suppliers. So the big issue or big challenge we have all together is also data flow between OEMs and the supplier. So we talk about Catena X, but it is a more industry thing. It is actually not only in the automotive industry, but also getting, if we're talking about battery, it is coming to chemical industry. So these holistic actions can be done only all together. So that is a big challenge to get it. But I think this Industry 4.0 technology gives a really possibility to do it. This CO2 footprint from the raw material until to OEMs. And the issue is also OEM don't like to have too many data. We do not want to. We do want to only the information which we need, if it is warnings or if it is the CO2 footprints or whatever. So it is already examples that it is working on. Example, IMDS material. That is already we getting from the raw material. If there is anything the toxic material is in, then we need to report it. So that is already working. So I have very good hope to get agreement with the supplier to get all the data exchanged and not all the data, necessary data. And also you can do some of temporary access for some specific issues or something like that.
Fascinating potential there. And Erich, there's a lot of focus there too on the supply chain and logistics, as we hear, understandably in the current context. When you think about alerts and monitoring critical inventory, what might be happening, this is clearly, for obvious reasons, become even more essential. Where have you seen, on the supply chain side, has this been a very active area for Microsoft as well?
Yeah, we actually just launched a new product for supply chain management. Our customers come to us and say, we're struggling to get a handle on our supply chains. Obviously with all the disruptions happening in the world, it's the only solution is to digitize as much as you can and have that information at your fingertips so you can make decisions more quickly, right? It's all about decision making because, when things run out, you really want to have a plan in place and be able to make a decision on what you want to do next. So I don't think there's any alternative to digitizing your supply chain, and of course Microsoft is trying to help. Yeah.
Any questions, comments from the audience? As ever, the floor is open. We have microphones around, so if you want to make a comment or a question, just put up your hand.
Just
yes, please.
One
yes,
please.
Please.
Because we have some of discussions with the supplier, and it is also if we share, we are getting more transparent, and also there is some of laws legally you do not exchange the data and so on. So there is also some of those things need to be revisited because this competitor laws and those things, what is the really the real data we can share it, we cannot share it. So that's also somehow work with the government to do it. And I think that's my personal opinion. It is some base of the data needs to be shared. It is oil for infrastructure, so data belong to there. Some of data, the top of data, you can do some individual development. But if we can get some data pools that we can use everyone, that will give us really a big advantage.
Absolutely. Okay, maybe one more topic to raise before we move into our final session, or two related topics, I suppose. You mentioned digital twins, Seonhi. I'd like to just, Erich, to hear your view. I mean, again, the buzzword is everywhere. We know there's different things happening. We know BMW has been digitizing a number of its factories, for example. So clearly it is happening. But is this how would you define the technology right now, and what's the potential that is still to come?
So the digital twin has many definitions, right? Depending on who you ask. I mean, for me, it's a collection of information in relation to a physical asset, right? So you're basically collecting data from usually different databases for a particular physical asset. It could be your product, right? But it could be also a machine that you're using. And you're bringing it all together in one central place. I think that's the best way to describe it. And of course, that means tapping into different aspects of your asset. You know, it could be a 3D model. It could be an OPC-UA information model if it's a machine, right? It could be, I don't know, the instruction manual that comes with your car, you know, that forms part of the digital twin. And again, you know, collecting all this information and making it available in a standardized format is the key to success, to be able to share that information with the people that need it. For example, your customers, or in fact, the suppliers need to provide that data to you also. You know, I mean, a lot of times, wouldn't it be great if you could integrate, like you mentioned, the virtual onboarding, integrate a new machine virtually by tapping into the digital twin of that machine, including, you know, integrating it into your manufacturing processes, you know, not just physically, but also on a digital side, and then being able to see, okay, it fits, it, you know, is compliant, it'll work with this, or I might have to change this other system over here to make it work. And, you know, being able to tap into digital twin technology allows you to do that for the first time.
And to really use the buzzwords and make sure we leave talking about the playing a bit of buzzword bingo here. Do OEMs need to have a metaverse strategy in the next phase for their production?
Well, I think so. I mean, the metaverse is something that, you know, is you know, just at the beginning of the hype. You know, it's probably at the top of the Gartner hype cycle right now. So, but there are actual customers that we work with that have made use of it. I mean, especially in the industrial space, if you have assets that are hard to get to, it's actually a good idea to build a, you know, virtual representation and use, you know, augmented reality or virtual reality technology to access it, just as if you were there, right? So, I mean, you know, oil fields or remote wind parks, offshore wind parks come to mind, but also solar parks in the desert, right? You don't want to drive out to the desert every time, you know, something goes wrong. So, I mean, obviously, a lot of people say, yeah, but, you know, I could just use a plain old 2D dashboard and I'll get the same information. That might be so, but I mean, once you've actually tried it, you know, trust me, you don't want to go back, right? It's a much more immersive experience, and it is really as if you were there, right? And, you know, you can try out different things and interact with the systems in new ways. So I really think there is something of value to be had from the metaverse, yeah. Mm.
And Seonhi, just as a last thought there, I mean, it wasn't on your deck there, but is metaverse now, is this the next evolution, a step for the digital twin and AI combination in terms of Ford's manufacturing engineering research?
Yeah, we have just started some of the project and to see how we can use it. And I think it's marketing guys stepping up to have a virtual customer, and to look up what happens if this happens. But it's also, I think, probably in the production, if if you have digital twin, probably more complicated detail levels. But if you can play the different, like game industry, say something, you can play it and to find out some concerns or some issues, that will help you. But we do not know yet, but it's an exciting area.
Indeed it is, and I think it's that exciting area that we'll sort of leave this discussion on. But thanks again to both of you for giving us this view. Again, as I said, not just the factory of the future, really today, with great examples. So exciting times ahead, and thank you for sharing more about them.
Thank you very much.
Thank you.
Thank you.